Good morning. Today I'm going to presenting my project Home Automation. My name is Afif S and I am currently pursuing BTech in Sri Chitradirthal College of Engineering, Trivandrum. This project was guided by Miss Jayalashmi and Daniel, Emertxe Technologies. This internship is a 1 month internship. During this internship I had learned about C programming, data types, syntax, identifiers, arithmetical operations, functions, pointers and so on, and also studied C++ also. So the table of contents are: first I am discussing about project overview, next I am going to objectives, introduction to IoT, IoT architecture, embedded system foundation, block diagram, results, and finally conclusion. So my project is the home automation project aims to design and implement an IoT based smart home control system that automates lighting and temperature regulation using sensors and actuators connected through the Blink IoT platform. The system intelligently adjusts lighting and thermal conditions based on real-time sensor readings, enhancing comfort and energy efficiency at home. The LDR sensor monitors ambient light levels to automatically vary the brightness of an LED, simulating garden light control based on sunlight availability. Simultaneously, a temperature control unit comprising an LM35 temperature sensor, heating resistor, and cooler regulates room temperature. The temperature value is displayed on a character LCD, that means CLCD, for local monitoring. Using the Blink mobile app, users can remotely monitor temperature readings and control the heater and cooler in real time. The system represents a practical integration of embedded electronics, sensors, and cloud-based IoT control, demonstrating sustainable home automation solutions. Next, the objectives of this project are: automatically control garden light brightness using an LDR sensor, monitor ambient temperature using LM35 and display readings on CLCD, remotely operate heater and cooler via the Blink IoT mobile application, and achieve intelligent energy management and smart home automation. Next, introduction to IoT. IoT means it is a technology that enables interconnected devices to communicate and exchange data through the internet, allowing automated and intelligent control of everyday systems. It bridges the gap between the physical and digital worlds by linking sensors, controllers, and cloud applications for efficient monitoring and management. In this project, IoT acts as a core technology enabling remote control of lighting and temperature in a home environment. The system uses Blink IoT platform as a cloud interface for device communication, allowing users to change home conditions through a smartphone app based on real-time sensor feedback. It is by IoT enhances home automation, making systems responsive, energy efficient, and user friendly. Next, IoT architecture. The IoT architecture for this project integrates sensors, microcontroller, Ethernet shield, and the Blink IoT cloud to enable remote monitoring and automated control of lighting and temperature systems. The architecture is divided into four functional layers that work together to ensure real-time data communication and system operation. The four layers are the perception layer, network layer, processing layer, and application layer. If we go to perception layer, we can see that this layer consists of LDR sensor and LM35 temperature sensor. The LDR measures ambient light intensity and adjusts the LED brightness to simulate garden lighting control. The LM35 detects surrounding temperature and sends analog data to the microcontroller for further processing. In network layer, the network layer uses the Ethernet shield, not Wi-Fi module. I here use Ethernet shield to transmit sensor data to the Blink cloud. We can alternatively use Wi-Fi module also. For this project I used Ethernet shield. So by Blink using Blink cloud, it also receives control commands from the user's mobile app in real time. Next, the third layer is processing layer. The microcontroller processes sensor inputs, executes logical conditions, and sends corresponding signals to actuators for stable IoT data exchange. Next, application layer. The Blink mobile app serves as the user interface. It visualizes temperature values, provides control buttons for heater or cooler, and displays system's real-time status. Next, embedded system foundation. The embedded system is a programmable hardware platform designed to perform specific tasks using both hardware and software components. In this project, the embedded control forms the core processing unit that gathers sensor data, executes control logic, and manages communication with the Blink IoT platform. The hardware components I used are Arduino Uno, LDR sensor, LM35 sensor, CLCD display, and heater and cooler. The main brain of the project is the Arduino Uno because it is for reading sensor data and controlling output devices. The LDR sensor measures ambient light intensity, allowing automatic adjustment of LED brightness for garden lighting control. LM35 sensor detects real-time temperature and provides analog output corresponding to the ambient conditions. CLCD display displays the current temperature value for local user reference. Heater and cooler are used to control temperature, activated based on LM35 readings and Blink app commands. The software components are Arduino IDE, Blink IoT platform, PixSimLab. I simulated the whole project in PixSimLab. Arduino IDE means it is the main programming environment used to write, compile and upload code to the microcontroller. Here I upload code to the PixSimLab. The Blink IoT platform enables remote control and real-time data monitoring through a mobile interface. Next, the main software is another main software is PixSimLab that is used for simulation. It is a real-time emulator and simulator designed for embedded microcontroller projects including Arduino and PIC microcontrollers. It supports integration with IDEs like Arduino IDE and MPLABX, allowing us to upload our compiled hex files and simulate hardware behavior virtually. The hardware platform is the Arduino Uno. We can know that it is the main central controller microcontroller board used in my IoT project. It features an Atmega 328P microcontroller operating at 16 MHz clock frequency with multiple digital and analog input-output pins allowing interfacing with sensors and actuators. The main features are it has 14 digital input-output pins and 6 analog input pins A0 to A6. A0 to A5 such as from LDR and LM35. It operates at 5 volt supply voltage and USB interface for programming and serial communication also. Next, Blink console integration. The Blink platform plays a crucial role in the IoT-based home automation system by enabling real-time remote control and data visualization. It acts as a bridge between the embedded hardware and the Blink IoT app. Through Blink, users can monitor device status, send control commands, and receive feedback wirelessly over the internet. Blink provides both cloud and mobile interfaces, supporting seamless integration for IoT applications. Each device connected to Blink is authenticated using a unique authentication token, ensuring secure communication with the platform. Next, the block diagram. This is the block diagram for garden light control. Here, three components: Arduino Uno, LDR sensor, and LED. The LDR sensor senses the value based on the reading from the LDR sensor reads the value, and based on this reading from LDR, the LED brightness will be vary, which resembles the garden light by control in based on availability of sunlight. Next, this is the temperature control system. It consists of a heating resistor, heater, a LM35 temperature sensor, and a cooler, which resembles a temperature control system at home. It reads the temperature from the temperature sensor LM35 and display it on the CLCD, and control the temperature of the system by turning on or off the heating and cooler through Blink IoT app. So this is control using Blink IoT app. Next, this is the water tank inlet and outlet valve control. Here, read the volume of water in tank through serial communication and display it on the character LCD, and control the volume of water in the tank by controlling the inlet and outlet valve, and display the volume of the tank in the CLCD. The inlet water flow will be enabled when it is full. The inlet valve is disabled. In the temperature control system, when the temperature is more than 35 degrees Celsius, the heater will be turned off. I programmed like this. These are the results I get when I simulated the project on PiximLab. Here this is the character LCD, and this is LED, this is LDR, this is temperature system, this is water tank, and this is the Ethernet shield. This is the interface of the Blink IoT platform. Here I used buttons for heater, cooler, inlet valve, outlet valve, and two gauges for temperature and volume. I am opening the PiximLab, and this is the code for the project. Here I gave the Blink unique authentication token. This is the control of the cooler, heater, inlet valve, outlet valve, and this is for reading the temperature, and this is for controlling the LDR. Here the cooler pin is V2, heater pin is V0, temperature gauge is V1, water volume gauge is V3, inlet valve is V4, outlet valve is V5, and the blink pin is V6. Now I am export compiling. There are no errors. Then I am opening PiximLab file, loading the hex file, loading the file home automation blink control INO, and open. This is the character LCD display home automation. This is LDR. This is LED. This is temperature system. This is Ethernet shield, and this is the water tank. I am pressing the cooler button. CLCD display cooler on, and the temperature cooler is on. We can see the cooler is on. If I press off, it shows cooler off. When I press heater button on, it shows heater on. We can see the temperature is increasing. The temperature is increasing. Yes, we can see the heater is off. Here we only seeing the heat off because I am implementing the two projects, water and inlet valve and outlet valve control, and also the temperature control system. That is why it show like this. If we press button on cooler, we can see the temperature on the LCD, and also at the same time we can see it on the Blink IoT app also. Next, I am turning on the inlet valve. The water is filling. We can see the inlet valve is on, and this is the volume of the tank, and maximum limit is 3000. When I press off, it is show inlet valve is off. When I press outlet valve on, the water will be reducing. We can also see the volume in the tank in the CLCD and also in the Blink IoT app also. So in conclusion, I had successfully demonstrated an IoT-based home environmental control using Arduino Uno, LDR LM35 sensors, and Blink mobile app integration. The system automates lighting brightness based on ambient light and regulates temperature using heater and cooler control via a remote interface. The future scope of this is we can expand system to include additional sensors such as humidity sensor, gas sensor, and motion detectors for comprehensive home automation. We can integrate voice assistant compatibility for more natural user control. We can implement machine learning algorithms for predictive automation based on usage patterns. We can enhance security features with IoT based surveillance and alert systems. We can deploy on advanced microcontrollers with integrated communication modules for higher scalability. The proposed system lays a foundation for developing intelligent connected homes that improve comfort, safety, and energy efficiency through technology. Here I use microcontroller Arduino Uno. We can also use STM32, ESP32 microcontrollers, and it is also are available in the Pixim lab. This is very helpful project. Thank you. One more thing to demonstrate that the LED is connected to the pin 3, and based on the values from the LDR, the LED brightness will be reducing, which resembles to the availability of sunlight in the garden light. When the sunlight is very less, the LED will be brightness more, and when the sunlight brightness is very high, the LED will be turned on. That means in the daylight it will be turned off, and in night the LED or the garden light will be turned on. So I had implemented three projects. That means one is the temperature control system, and second one is the garden light control system, and third one is water inlet and outlet valve control system. I think this these three projects are very beneficial for an home automation. So if uh, by using Blink IoT platform, we can control this from everywhere. So thank you.